All right, continuing with chapter 8, and this is a section 8.3, and we're discussing Charles' law, the temperature volume relationship. All right, so if we increase the temperature of a gas sample, what happens is the kinetic energy of the gas goes up. All right, they become more energetic, and when that happens, what will happen is if you keep the pressure constant, you keep the amount of gas constant, the volume has to expand. This is what you see in a hot air balloon. Pressure is constant, the atmospheric pressure. The amount of gas is constant, but as you heat up the air inside the balloon, it's expanding, and then the balloon will rise. So in Charles' law, because of the direct relationship, when one increases, the other one increases as well, as you can see here. Okay, so the volume was initially 1 liter, the temperature was 200 K. As you heated up the gas, the particles became more energetic, and they kind of pushed against that piston and expanded, right? And the temperature has doubled and the volume has doubled as well, showing a direct relationship. All right, so that takes the form V1 T1 is equal to V2 T2. Okay, pressure in moles are constant. All right, so if you have to solve for V1, then you have to multiply V2 by T1. Okay, this is a typo. I'm sorry, rearranging to solve for V2. So if you want to solve for V2, then you have to multiply both sides by T2. So V1 T2 divided by T1. If you multiply here by T2, they cancel. And so V2 takes the form V1 times T2 divided by T1. If you're solving for V1, then multiply both sides by T1. So it will be V2 T1 divided by T2. Okay. The best way in order to not get confused is rewrite Charles' law with opposites. So V1 opposite temperature T2 is equal to V2 T1. All right. Use this form of Charles' law, and then you can solve for unknowns rather easily other than trying to manipulate that equation. Okay, so write it this way: opposite volumes and temperatures. So when you're solving for T2 using this form, then it's pretty easy. You divide both sides by V1. Okay. All right, a balloon has a volume of 780 mils at 21. Remember, never solve gas law problems in degrees centigrade. Always convert it into Kelvin. If the temperature drops to 0 degrees, which is 273, what is the new volume? So the volume has to go up. So V1, 785 times 273. V2 times the 294. Okay. So you're going to divide so you're going to multiply 785 times 273 divided by 294. Okay, and you'll get 729 mils. So the temperatures come down, and so does the volume. So sample of oxygen has a volume of 420 mils at a temperature of 18 degrees centigrade. What temperature in degrees centigrade will the volume of oxygen be at 740 mils? Remember, even though they want the answer in degrees centigrade, convert first into Kelvin and then reconvert back the answer into degrees centigrade. So it's opposites, 420 times T2 is equal to 640 times 291, all right? So 640 times 291 divided by 420, that should give you the answer in Kelvin, and then subtract 273, okay? So you get 443 and subtract the 273 and 170 degrees centigrade B. So use the gas laws to complete each sentence with increases or decreases. Pressure increases when volume decreases. Temperature decreases, volume decreases. Pressure will decrease when volume changes from 12 liters to 24 liters. Volume will increase when temperature changes from 15 degrees centigrade to 45 degrees centigrade. All right, we'll stop here.